Okay, here student investigated the photoelectric effect using the apparatus shown. Right here we have a color filter and photocell and connection to ammeter and potentiometer and a digital voltmeter. He used a source of white light and color filters to shine different wavelengths lambda of light in onto photocell. Photoelectrons were emitted with a range of kinetic energies, creating a small current in the photocell. Using the potentiometer, the student varied the potential difference across the photocell. As the potential difference across the photocell increased, the current in the photocell decreased. Okay, that's a kind of important point. What right, using the potentiometer, the student varied the potential difference across the photocell. As the potential difference across the photocell increased, the current in the photocell decreased. Right, he measured the potential difference Vs when the current is in the photocell was 0. He calculated the maximum kinetic energy of the photoelectrons each wavelength of light, and here we have the table shows the students data. Right now, then what should we do? Right here in the first one, plot a graph of maximum kinetic energy on the y-axis against 1 over lambda on the x-axis on the grid opposite. Use the additional column in the table for your processed data. Right, so I just paste here the marking scheme that they have given to explain you what's going on over here. Right, and you can clearly see what they have given mark for calculating correct round correct values rounded off to 3 significant figures. Right, here we have 3 significant figures, and here also we have 3 significant figures. Right, we don't care about these zeros, we call it placeholders. Right, here 3 significant figures, 3 significant figures, 3 3 3 over here, and 3. So you can either use this one or use this one, whatever you prefer. Right, for calculating that one you will get 1 mark. Then for even labeling your axis, right, axis with the quantities and the units. Right, here y axis we have to take as our for energy. So it is they have given, right, it is 10 to the power minus 20 joules, so you have to place it over here. Right, for labeling that one. And here also we have 1 over lambda, and it is 10 to the power minus 6, or it is 10 to the power 6, 10 to the power 6, sorry, not minus, sorry, it is 10 to the power 6. Right, we have to label those two. For even that one, right, they give marks for you. Right, here labeling with quantities and units, 1 mark. And for the scales, right, you will get another 1 mark. Right, for even scales, and those scales should be sensible. Here you have to measure, check your range. Here for Emax, it is starting from 5.6 and 13.9. What they have done here, it is 15 the maximum value, and it is 5 lowest value. Right, so we can divide it into 6 7 like that. Then we can place our points on that axis. Then what about the lambda? It is 1.61, and starting from 1.5 if we take it, and it is going to 2.29, 1 point from 1.61. Right, here they have taken it is as 1.6, and this here it is 2.40. Right, what you can do, when I was a kid, I used to find the range and count the number of squares. Normally if you, right, they will give the same graph paper, so you don't need to worry about that one. In a one square we have 10 squares in one big square. Then we have 1 2 3 4 5 6 1 2 3 4 5 6 7 8. So it will be 8 small squares. So by using this number of squares you can calculate the range. Right, it is just, you need to take, it is 1.61 and 2.29. so we all know it is 16 to 24. Right, we have 8. So if it is 1.60 and 2.40, right, we have 8.0 between them, the difference between them. So if we have 80 small squares or 8 big squares, we can choose this range. So it should be something up to 8 8 or 4 or whatever you prefer, or even 5 you can take. The most preferred one are scaling by 2. It's kind of a little complex. I don't think about that, and I'll explain it in another video, right? Here, then what about this one? We have 1 over here, 2 3 4 5 6 7, right? 8 9, and here it is 10. So we have 100 squares. So you have to make sure your the y-axis range within a range of 100. So if we start from 5.0, right, and it is 15.0, and we have 10, so we can divide it into 10 parts, right? Okay, then you can choose a correct scale, so 1 mark for that one. And plotting the graph, right, for this plotting, right, you will get 2 marks, right? And for the line of best fit, you will get 1 mark. Here you will get 1 mark, right? Then that's it, right? In the next question, the relationship between the maximum kinetic energy Emax of the emitted electrons and the wavelength lambda of the incident photons is given by the equation, this one, right? Show that the Planck constant h is equal to gradient of graph over C. So in our graph, Emax is y-axis, right? So we need to subject that one. If I subject that Emax, right, it is h c over lambda, c over lambda minus phi is our equation, right? Then we have plot the graph, what, for 1 over lambda. Our graph is 1 over lambda. On the x-axis we have 1 over lambda, right? Here it is 1 over lambda, right? So I'm going to put my values, let's see, like this, and 1 over lambda. So we have here it is y-axis, here it is x-axis, here it is intercept C, and then here it is the gradient, right? Okay, then this is a y equals mx minus c type of graph. So you can write it like this: E max is equal to hc 1 over lambda chi. So it is y equals mx minus c type graph. So gradient is m is what, hc. So you can find what, your Planck constant by dividing the gradient from the speed of light, which equals c, right? Then you will get 2 marks, and your marks are given to subject in this one and placing it for these algebraic expressions like this, 1 mark, right? Then here they are asking us to determine values of h. How can we determine that one? We need to measure the gradient of this graph, right? By using what? By using large triangle. So here you should choose your triangle, right? And you should mention it like this, right? So right, then this is your triangle, and here it is delta y, here it is delta x, and m equals delta y over delta x, right? How can you calculate delta y? Right, by taking the difference between these two values here and here, and delta x is take the difference between these two values. I hope you know these things, right? Then how can we calculate that one? So I'm going to use the gradient that they have given in the marking scheme, right? The gradient is equal to but they have taken the data points like 12.8 and 6.6. You can take what you prefer, but your triangle should be larger, right? At least more than half of the graph, right? Times 10 to the power 20 joules over 2.2 minus 1.7, right, times 10 to the power 6 meters. So if you calculate this one, you will get what, 1.2 1.24 times 10 to the power minus 25 joule meters. Sorry, if you calculate gradient, I'm sorry, h is equal to gradient over c, so h value will be the gradient. Here it is 1.24 times 10 to the power minus 25 joule meters over 3 times 10 to the power 8 meters per second. So m will be cancelled out, units will be joule second. So if you calculate this one, you will get the value 4.13 times 10 to the power minus 34 joule seconds, right? So you don't need to get this exact value. They have always given a kind of range in their marking scheme, so your value should be in between this range, 4.0 times 10 to the power minus 34 joules and 4.3 times 10 to the power minus 34 joules. Your value should be in between this range, right? Then your value should be rounded off to 3 significant figures. So I'm going to do this one, 2 or 3, right? 3 times 10 to the power minus 34 joule seconds, right? Here they are asking us to calculate the percentage difference between this the accepted value of h and this value, right? How can we do that one? I hope you remember we have done it in the previous questions, right? Percentage difference is equal to 6.63 times 10 to the power minus 34 joule seconds. That is the exact value, and the value we calculated is 4.13 times 10 to the power minus 34 joule seconds, and we need to divide it from the accepted value, 6.63 times 10 to the power minus 434, right, joule seconds. So your units will be cancelled out, you don't have to worry about that one, and you should multiply this one from 100%. So if you calculate this one, you will get 38%, a massive percentage difference, right? A massive percentage difference, right? The student's investigation involves a small random error and large systematic error. For each of these, suggest the source of the error and a realistic modification to the procedure which would reduce it, right? I hope you know what are random errors and what are systematic errors. Random error is that is random for each and every measurement. We can't ensure what will be the error, right? Systematic error, it will be the same error for each and every measurement. So what are we gonna face as our random errors in this experiment, right? First thing is, right, it is really hard to difficult to judge, right, what is the exact point when the current becomes zero, right? It is difficult to identify. Or another one is the background light also could be affected for our experiment, right? So you can write one of these two. So I'm going to write difficult to judge, difficult to judge exactly when current becomes zero. For that, the modification is, I'm going to write over here, right? Use more sensitive ammeter. And another reason, you need to only write one. I'm just writing two because they have given 2 points in the marking scheme. The other one is a background light could be affected wavelength or the color. Could be affected, right? Affect wavelength affect, right? V effect, right? So how can we modify this one in a realistic way? We can block the background light, right? These are random errors. So what are the systematic errors we're going to face in this experiment, right? And what the, like, you should be able to tell this, and what the color filters do not give monochromatic light, right? We need monochromatic light source. So can write what color filters color filters do not give what monochromatic light. How can we modify this one, right? Use a monochromatic light source. The monochromatic light source. Or another systematic error will be what zero error of the ammeter or voltmeter. Either, so how can we modify that one? Uh, check for zero error. Check ammeter reading is zero when no light is shining, right? Check uh, ammeter or ammeter reading or voltmeter reading. Then no light is shining, right?